So we want to remember that the cosine of an angle is really asking for the x-coordinate at that angle. So if you know the coordinates at 30 degrees on a unit circle, well, the cosine of that angle is simply the x-coordinate of that point. The sine of that angle is the same thing as the y-coordinate at that point.
Quick thing. Can I tell you something?
Yeah, what's up?
I don't see your screen at all.
It's probably because you're on the phone. Can everyone else on the call, can you see my screen? Can someone else answer?
Yeah.
Okay. So yeah, I don't know if there's some setting on the phone or something to allow you to switch to the presentation.
Well, it says you're presenting, but it's just a black screen.
Sorry, I do not know why that's happening on your device, unfortunately. All right, so these exact values, if you know the coordinate, well then the cosine of the angle is just the x, the sine of that angle is just the y coordinate, and then also we have the tangent. And if you remember, like SOHCAHTOA, tangent is simply the opposite over the adjacent, or the y divided by the x coordinate. So we want to keep that association. Luckily, this is pretty easy because if you look at each of these, it's alphabetical. Like C comes before S and X comes before Y. That's how I still keep it straight myself even. I just remember, oh, if it's cosine, well, alphabetically that comes earlier in the alphabet, so that's the X value. So now something like sine of 30, to get this exact measurement, the exact value, instead of typing it into the calculator and getting some irrational decimal, well, I can simply look at my unit circle or just think about it, which is where we're going to eventually get, and think about, well, what are the coordinates at 30 degrees? Which we came up with this on Wednesday by drawing that special right triangle. And this had an x-coordinate of √3/2 and a y-coordinate of 1/2. And since this is asking for the sine of 30 degrees, I simply want the y-coordinate at 30 degrees. And so I simply look at that coordinate, I'm like, oh, well, the y-coordinate's 1/2. That means the sine of 30 degrees is 1/2. And if you do type that in your calculator, you get 0.5. Now for something like tangent of 45 degrees, well, let's look at the 45-degree angle. That's simply the square root of 2/2 and another square root of 2/2. So those are the coordinates at that point at 45 degrees, and that comes from a 45, 45, 90 special right triangle on the unit circle. Tangent is the y-coordinate divided by the x-coordinate. Well, since my x and y are the same, everyone, what's going to happen when I divide those two numbers? It equals 1. Yeah, if I took √2/2, I divide by another √2/2, we get 1. Using that quadrant 1 unit circle that we created on Wednesday, can you try to figure out these next 4 on your own? Take a look at them and see if you can identify each of those. You actually have it right here too in the notes. This is quadrant 1, so I don't know if you can. I mean, they're kind of tiny. So take a minute, and can you identify those other 4 trig ratios by simply looking at the coordinates on your unit circle at each of those angles? Sure. You're welcome. right, did we get through each of those angles? I'm going to jump over to the right, to the sine of 45 degrees. So you already know the coordinates of 45 degrees. It's the same x and y, root 2 over 2, root 2 over 2. Sine is the y coordinate, so that's just the square root of 2 over 2. Now, tangent of 90 degrees. This one's a little different. And think about the coordinates at 90 degrees. 90 degrees is straight up, like on the positive y-axis. So if you go straight up, what would the coordinates be? If I don't move left and right, I just move up 1 unit. What are my coordinates? Thank you. Yes. Good. The one student who didn't even see the lesson has the answer. Thank you. That's awesome. 0, 1. Now, tangent is the y-coordinate divided by the x-coordinate. And so if I wrote that as a fraction, I'd get 1 divided by 0. Can we do that? We can't divide by 0. So because of that, the tangent of 90 doesn't exist. We would say that it is undefined. If you type that into your calculator, tan 90, you will get an error. Doesn't work because that whole dividing by 0 thing is tricky. But the cosine of 90, we can actually determine that. It's going to be the same coordinate, right? Because it's 90 degrees. That's the point 0, 1, straight up above us. And the cosine of 90 just means the x-coordinate at 90 degrees. So what is the x-coordinate at 90? Just a 0, sure. Now, does that mean no solution or undefined, or it equals 0, right? 0 is an actual number. It's a value. It can actually be that value, right? The cosine of 90 is exactly 0. Then finally, we have the cosine of 30 degrees. Now let's look back up here at our 30-degree coordinate. Cosine, is that the x or the y? Think about that first, and then just tell me, what's the cosine of 30 going to be? Go ahead. It's perfect. Yeah, the x-coordinate is the square root of 3 divided by 2. So if you have that unit circle, figuring these out is very, very simple. But it's getting that to your memory. And so today it's going to be working on that some more. I'm going to give you a few little math tricks and strategies for learning this without having to actually sit there and memorize that. That's scary, isn't it? It's a little intimidating. Anyone a little excited about this? Yeah. No, not one hand. Okay. We tried. So that's what we're going to be doing today, figuring out, hey, what's the whole thing? But if you look at all those values, like if you look at these numbers here, these coordinates, compare them to these. What do you notice? Yeah, same numbers, just negative. Because if you're in quadrant 2, isn't just x negative in quadrant 2? That's it. If you look at all 4, you'll notice that the same thing applies. That's why I had us starting by just focusing on quadrant 1. Because if you have quadrant 1, you can get the whole circle, no problem. So here we go. There are 3 different parts of the unit circle that we need to learn. Here, let me go back real quick to show you. For the unit circle, we want to know each of these different angles. We need to know their measures in degrees. That should be pretty simple, right? The different degrees around the circle. We're familiar with a lot of those. Then we need to know those same angles in radians, which is this new unit that we just learned with a pi in it. And then we need to learn the coordinates at each of those. So if I were to ask you the sine of 30 degrees or the tangent of pi over 4 radians, you would be able to think of the coordinate at that angle and then easily tell me what that value is exactly without needing that calculator. So I'm going to go through each of those 3 different parts of the unit circle, figure out how to recreate it. Again, this is nice because you don't have to sit down there and memorize that whole thing. That would be terrible. That would be awful. So there are 2 quick, easy ways to kind of remember all of the angles on the unit circle as you kind of spin around it and starting at 0. What are the values? One of the easiest ways that I've seen students do is just simply adding in this pattern. Starting at the 0 degrees, which is to the right, the positive x-axis, you just add 30, then 15, then add another 15, then add another 30. You're going to get all the values in that one quadrant. Then you just repeat that pattern for each of the 4 quadrants, and you're good to go. Method 2 is using reference angles. If you remember, that's the little angle, the distance away, the acute measurement from the x-axis. So we're going to take a look at both of those methods. You can decide which one is nicer for you. So here's how this adding method works. You just start on one axis. So for example, at 0 degrees down there. And you add in this pattern. You add 30 to that number, and you get 30 degrees. Then add 15, you get 45. Add 15 to that, you get 60. Add 30 to that, and you get 90. And boom, there are all the angles in that quadrant. You just have to remember the pattern, 30, 15, 15, 30. But that exact pattern then will just continue to repeat all the way around the unit circle. So right here, I'd like us to do this together right now. We start with 0 degrees on the right. That's at the positive x-axis. So let's try this adding method. You add 30 to that first angle, and well, you get 30, right? That's the easy one. Add 15. Well, 30 plus 15 is 45. 45 plus 15 is 60. And then 60 plus 30 is 90. So look how I'm adding 30, 15, 15, 30. And that got us up to 90 degrees. From here, we want to repeat that pattern going into quadrant 2. But it's going to be the same thing. So add 30 to 90, and we get 120. Add 15, you get 135. Add another 15, you get 150. And if you did the pattern correctly, if you add 30 again, you should have 180 on the left. Go ahead and finish the entire unit circle for me using that pattern. Go all the way around all 4 quadrants to see if you can get all the angles in degrees. Down at the bottom, at that like negative y-axis, you should have a 270, just to make sure that you're tracking and getting it right.
Since you are pretty smart with numbers. So as soon as I open up my calculator or whatever, like my mouse just kind of like starts to lag, you know? Would you have any idea?
And whenever that calculator is open, it's always lagging.
Like whenever, like I just so it was open, and then when I was typing in these, it started lagging. So I tried signing out to re-sign in.
Yeah.
And then it's back to doing the same. It's like lagging.
So even like whenever that calculator app is open,
yeah,
there's just a delay with the mouse.
The mouse is kind of like delaying when I'm moving it at times.
Huh. I'm really not sure. Oh. I haven't seen that happen with anyone else's Chromebook ever. Oh. That's annoying.
Yeah, that's what I was experimenting with this too.
Yeah, sorry, man. I don't have a better answer for you.
Oh, really?
That looks good. Awesome. Okay, good. I think we got it, right? The pattern continues all the way around. So then you get 210, 225, 240, 270, right? Add 30, 15, 15, 30. Add 30, you get 300. Add 15 to get 315. Another 15 to get 330. And then if I were to add 30 one more time, we'd get all the way back to 360. One complete revolution around that circle. And of course, these are all in degrees, because later we're going to do the same thing, but in radians. All right. Any questions on that? Does anybody here think they could recreate this on a test by themselves right now? If I gave you a blank circle, could you write all those angles in degrees? Probably. Yeah. That's a piece of cake, right? No issue whatsoever. 30, 15, 15, 30. What's that? Yeah. Yeah, that'll be part of your test. All the angles in degrees. Yes, you will be tested on doing that. You excited for that one? You got 2 weeks. 2 weeks to practice it to make sure it. Now, the other way is thinking about reference angles. And here's the idea with that. There's just another way to think about this, right? You don't have to do it this way, but this is more mathematically what's going on. We know that our three angles are 30 degrees. The next one is 45 degrees. And that next one up there is 60 degrees. In every quadrant, those three lines are going to be those exact same measurements. So like if I go over to quadrant 2, for example, that line that's closest to the x-axis, that's going to be a 30-degree angle as well. And if I know that this is 180 degrees, I can just kind of think, okay, well, if I start at 180 and I go backwards 30 degrees, what number would I be at? And you can be like, oh, well, 180 minus 30, that would actually give me 150, because it has to have the same reference angle. They both got to be 30 degrees away from the x-axis. I can do that for the next one too. If I know, oh, this angle is 45 degrees, because that's the next like reference angle. So just think, if I started from 180 and I went back 45 degrees, what number would we be at? Well, that's 135. Then same thing with that third reference angle of 60 degrees. If I'm at 180 and I go back 60, I get 120 degrees. And so every one of these, in every quadrant, they're going to have those same three reference angles. And so that's just a different way of thinking about it. Instead of doing the 30, 15, 15, 30 pattern, both are going to get you the same values. So like if you go to quadrant 3, same idea, but instead of going backwards, you're going forwards 30 degrees. So you'd take 180 plus 30, and you get 210, and so forth. So then add 45 to it, then add 60 to that 180. Over here in the last quadrant, you're going backwards, not from 0, but you're going backwards from 360. But it's still the same idea. That smallest angle is 30 degrees. And so from 360, if you go back 30 degrees, you'd be at 330 degrees. So that's another way to get each of those degree measurements. And eventually you're just going to learn these numbers because we're going to use them so often that, by next year in pre-calc, you're probably going to know these off the top of your head just because we've calculated things with them so often. But for now, it's just nice to kind of help you get started learning them. So that's all the angles in degrees. Next up, angles in radians. Dun, 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 dun. So these are this newer unit of angle measurement for us that we're probably not as familiar with. And a great way to think about each angle, and first off, one thing that you could always do, remember, is just, if you know the angles in degrees already, you can easily just convert them into radians by using your conversion factor. Like if I had a 30-degree angle, what could I multiply that by to get that same angle in radians? That's right. The pi would go up top, 180 would go on the bottom. I sincerely hope everyone can answer that because you're being tested on that today, on doing something like this, right? Converting between degrees and radians. That's target 9.2. So I was a little scared there when it was kind of quiet for almost a minute straight. Whew. You multiply these out, the degrees cancel, and you've got, and the zeros cancel out, so you got 3 pi over 18, or that simplifies to pi over 6. All right, so if you know all the angles in degrees, you can easily just convert them each into radians by using that conversion factor, but that takes more time. I want you to be able to think about each actual angle in radians. So the best way to do this that I found out in my vast years of experience is that it really helps to think of pi, this new radian kind of value, but think of pi as an actual pie that you're going to eat, and you're cutting it up into different slices. Do Do you like pie? No. Oh. What do you think of it as like cake or something? All right, so this is your cake, not pie. So what we're going to do is we're going to cut up the pie, the pizza pie. I think that works, right? We're going to cut up the pizza pie into fourths. I'm going to take each pie and slice it into 4 equal slices. And basically, you just count up the number of slices that you have. And that's going to be your angles in radians. It's a really cool way to think of it. So let's start by taking our pie right here, our pizza pie. Now, there's one issue. Generally, a pie or a pizza is completely round. But on our unit circle, does pie, a single pie, is that all the way around the circle? No. Where's one pie actually end? At 180 on the left. Good. So we need to think of that marker as being one complete pie. So I'm just looking at the top half here of this unit circle. If that were one pie, and I were to cut it up into 4 equal slices, here's how you can easily do that. I'd start by taking one slice right down the middle, right? Like right at that 90-degree mark. And then cut each of those halves in half again. So then you've got this diagonal and the other middle diagonal. And if you look at that pie now, that top half, we have 4 equal size slices, don't we? Starting from 0, so here's 0 right here. If I just took this first slice, that's saying that, hey, I have 1 slice of pie out of how many? How many total slices did we have? How much of the pie is this? What fraction? It's 1/4, isn't it? I have 4 slices. I'm taking one of them. That's 1/4 of the pie. Or just pi over 4. And that's what that measure is in radians. It's pi over 4, that 45 degrees. Okay, well, what if I added another slice? Now, each of these are the same size, so each of them are 1/4 of a pie. But how many slices do I have now? We have 2 of them. So you can think at this point, I've got 2/4 of that complete pie, right? I've got 2 slices out of 4. But can I simplify that fraction? If you have 2/4, what fraction do you really have? You have 1/2. Or we would say pi over 2, right? Pi divided by 2. Let's take another slice. Now how much do I have? What fraction of the pie do we have at this point? 3/4, exactly. So that angle right there is 3/4 of pi, or 3 pi over 4. It's literally 3/4 of a pie. And if we were super duper hungry, we took that last slice. Well, how much of the pie did we eat? The whole thing. If you think of it in terms of slices still, we actually ate 4/4 of that pie. But isn't 4 divided by 4 just 1? So over there at 180, that's the entire pie. What do you think? Can you handle that? 1/4, 2/4, 3/4, 4/4? And those are those angles in radians. But now we didn't do the entire circle, right? Let's look at the bottom half. The bottom half is an entire additional pie, right? There's a whole second pie there. What we're going to do is we're going to cut that pie up into fourths again, the same way we just did that top one. So take your knife, your pen or pencil, and I'm going to cut it right down the middle first at that 270 line, and then cut each of those in half as well. So we should have 4 equal slices on the bottom. Now each of those slices is still the same size as we had up top, meaning each single slice represents 1/4 of a pie. But now what's going to happen is once I take this next slice, I don't just start at 180. If I started at 0, count up how many slices do I have altogether at that point? 1, 2, 3, 4, 5, don't we? We have 5 slices, but they're still all just 1/4 of a pie. So we'd actually write this first angle as 5 pi over 4. Because the sides of those are still a single fourth of a pie. I just have 5 of those slices all together. So that's 5/4 of pi. Let's add another slice. If I had 5/4 and I add another, I now have how many fourths? 6/4. Exactly. So straight down, that'd be 6/4 of pi. We can simplify that fraction though, right? 6 over 4. That's the same as 3 over 2. So I'm going to write this angle as 3 pi over 2. This, so like 6/4 times pi, if you think of it as like a fraction, that's like pi over 1, right?
But if you write it as like 6 pi over 4, or is that like a different?
Well, you'd want to simplify the fraction to write it like this. The last number that I always write is the number that I want you to do. And if you look at my unit circle over here, you'll see that that's how it's actually written, 3 pi over 2.
But like, say you like write it as like 6 pi over 4 and then simplify it,
You'll always get the same thing. It's just if I had like 2 fractions here, we'd want to just multiply them together, try it as a single fraction. And this is how you're going to see it everywhere, as 3 pi over 2, not 3/2 of pi. But yeah, it is still equivalent, still the same thing. Okay, I had 6 slices. I'm adding one more. I now have how many slices? Got 7. So this next one is 7 pi. That's a bad pi. 7 pi over 4. And that's that angle. Last thing, if I add that last one, well, if I had 7 slices, I'm adding an 8th slice. So this last one would be 8 slices of pi out of 4. But what is 8 divided by 4? That's just 2. So this is actually 2 pi. Is that what we should have gotten when we went all the way around the circle? 2 pi? Absolutely. It's 2 pi radians. No. No. So that's some of the angles in radians. But do we have some lines there that we didn't identify yet? We did. We've got like the 30 and the 60 degree angles. So we're going to do that exact same process. But the only difference, instead of splitting it up into fourths, we now have to split it up into sixths. But then it's the exact same thing. You're counting up 1 6, 2 6, 3 6, and so forth all the way around the circle. Same exact idea. So I just have a brand new clean one for you because there was a lot of stuff we wrote on that last one. So I gave you a whole new slide for this. But we're going to do that same process, knowing that on the far left, 180 degrees, that's pi, that negative x-axis, that's 1 whole pi. Now let's take that pi that someone gave you for your birthday, and you had 6 people attending, so you need to cut up into 6 equal pieces. So let's slice this up into 6 equal parts. So I can cut it right in the middle, just like before. Let me draw my pie. But then those 2 halves each need to be 3 pieces each. So I'm actually going to make that first quadrant into 3 equal sized slices. So you're basically skipping over that middle line, that one middle diagonal. And we now have pi split up into 6 equal slices. We start at 0. Let's take 1 slice of that pi. Well, what fraction do I have? That's 1/6 of the pi, right? I took pi into 6 pieces. I'm taking one of those pieces. That's 1/6 of pi. We would just write that as pi over 6. If I take a second slice, well, now I have 2/6 of that pi, right? I'm just adding an additional slice. 2/6 of pi. But we can simplify that fraction. 2 over 6 is the same as 1 over 3. So this is 1/3 of pi, or pi over 3. I'm so hungry though, so I'm going to take a third slice. That's 3/6 of my pi, which is the same as pi over 2. Now we actually already had that angle from when we broke it up into fourths. That was 2 pi over 4th. So as you're doing this all in the same unit circle, you can kind of just skip over that one. You'll already have it written out. But I just want to show you that even if you break it up into sixths or fourths, you're going to get the same value. All right, let's take a fourth slice of that pi. So that's 4/6 of pi, or 2 pi over 3. That would be at the 150, nope, that's the 120 degree mark. All right, let's take a fifth slice of pi out of those 6 possible ones. So that's 5 pi out of 6. 5/6 of that pi. I've got 5 slices out of those 6 possible slices. And finally, if I take that last piece, I've got 6 slices out of 6. Well, 6 divided by 6 is just 1. I've got the whole pie at this point if I ate all 6 of those slices. Does that help a little bit, thinking of it like an actual pie? And like cutting it up into slices, even if you don't like real pie? Just like when we went into fourths, we're going to do the same thing with the bottom half by breaking that second pie into sixths as well. So I'm going to do one right down the middle and then break each of those quadrants up into 3 equal sized pieces. So we're basically skipping over that perfect diagonal, that one that would be at 45 degrees. We're skipping over it, just doing the 30 degree and the 60 degree reference angles. And remember, when we left off, we had 6 slices out of 6. So if I had one more, if you count those all up, 1, 2, 3, 4, 5, 6, this would be my 7th slice of pi. So that fraction, that angle in radians, is 7 slices of pi out of 6, or 7 pi over 6. Add one more. And we're going to have 8 pi over 6. We can simplify that fraction to 4/3. So that's 4 pi over 3. All right, that was 7, 8. So now we're at 9 slices at this point. We have 9 pi over 6. Now we should already have that angle also done from when we broke it up into fourths. That's the same as 3 pi over 2. Let's add a 10th slice. That's 10 pi over 6, 10/6 of a pi, right? Each slice is 1/6. I have 10 of them all together if you just count them up. That simplifies to 5 pi over 3. I make that 5 a little bit better. So it's 5/3 of pi. Add in the 11th slice. That's 11 pi over 6. No simplifying there. Then finally, we add in that last piece. Oh, got to keep my color scheme. That'd be 12 slices of pi out of 6, but 12 divided by 6 is 2, and we get over to 2 pi. Whoa. Do you think if you practice doing this 1 or 2 times that you'd be able to do it on your own? Just adding up fractions of a pi? Just fourths and then 6, and you're going to get every angle then. I always just take 2 trips around. I always spin around at once, just doing each fourth, then I go a second time doing each sixth. And that's how you can get each of those angles in radians. Any questions on how I got any of those fractions yet at this point? Get them all down? Awesome. All right, one last thing. The coordinates, all those root 3s and root 2s and halves and craziness. But guess what? As we saw on that opening slide, when I showed you the entire unit circle, we already kind of recognized that all those coordinates, all those numbers are actually the same. It's just some are positive, some are negative. So here's the best way to do it. If we can figure out just those coordinates for quadrant 1 really easily, all I need is quadrant 1's coordinates. Because once I have those numbers, I know what they are in all the quadrants. I just have to think of, oh, what, is it going to be positive x or negative x, positive y or negative y? Because they're the exact same values. So you don't need to actually try to memorize everything. If I have them just for quadrant 1, I can just kind of like reflect those or flip them over into the other quadrants, and we'll get those values. And then the last thing is just we need to determine, all right, which one of these would be positive and which one would be negative. And that's easy enough because you know how a coordinate plane works. You know how like x is negative to the left, but x is positive to the right. But that first step, that's going to be the tricky part. We have to memorize all those different angles. So here's quadrant 1. And let's say you do get to this point, you completely blank out and you forget, oh my gosh, what are the coordinates like right here? I don't remember this. One thing you can always do, that's kind of like your fallback, that you do know how to do is, well, what if we just draw the triangle? This is how we came up with these coordinates in the first place back on Wednesday. We know that the unit circle has a radius of 1. Then using your special right triangle properties, you could figure out those other 2. You could figure out, oh, this is 1/2, and that's root 3 over 2, using your knowledge from special right triangles. So you can always recreate these, and you can just put those values down and be like, oh, this is root 3 over 2, comma, 1/2. So again, you don't need to memorize that. You shouldn't have to memorize it. It's using all of our previous skills to write that. But I've got some good news for you. I've got a really weird, crazy shortcut, like a cheating method, to figure these coordinates out. Do you want to see that? Really quick, easy, crazy, amazing shortcut that's going to make it super easy to write this all down? Or should we just move on? And you can just memorize it yourself. No, you want to see this. You got to see this. You got to see this. It's really crazy how it works. But I'm going to warn you. In order to do this method, you've got to be able to do one specific math skill. You have to be able to count from 0 all the way up to 4. Can we handle that? Can we go from 0 all the way to 4? But we have to do that twice, though. You have to go from 0 to 4, and then you have to go from 0 to 4 again. Can we count that high? Max out at 3. Ugh. All right. Well, see if you can make it one more just for today. Here's what we're going to do. You got these lines already drawn for quadrant 1. We're going to start at 0, because that's always a good place to start, right? At the 0 degrees. And I'm going to write a number down. But first, we're going to write 2 coordinates, right? An x and a y coordinate. Let's start with the y coordinate. So like skip a little space from that right arrow, and you're going to write the number 0, because that's at 0, right? We always start at 0. But leave a little space to the left of it for another number. Now, all we do from here, for each of those other angles, is we just count up to 4. That's 0. I'm going to write 1, 2, 3, and then 4. What do you think? Can you handle that? We went all the way up to 4. Is that okay? Now that we made it all the way up to 90 degrees, we're going to do that exact same thing, but dropping down that stair. So I'm going to start up here at 0 and go 1, 2, 3, 4. And you should probably put a comma in between these because it's an x and a y coordinate. You want to separate those two numbers. So 0 to 4, and then 0 to 4. Okay, that's the most difficult part. Now you're thinking, wait, this is ridiculous, Wojcik. What do we do? Well, now what I want you to do is for every single one of those numbers, both the x and the y coordinate, every one of those angles, I just want you to simply write the square root symbol above every single one of those numbers. Square root, square root, square root, square root, square root, square root. On every single one of those 10 different numbers. Put the square root sign above each one of them. Take the square root of all those numbers, and one last thing we have to do is divide every one of those by 2. So you're just going to write all of them over 2, over 2, over 2, over 2, over 2, over 2. Over 2, over 2, over 2, and over 2. Now here's where this gets crazy. Go ahead and simplify every one of those numbers that you can. And watch what happens. Let's start down here at 0 degrees. What's the square root of 4? And what's 2 divided by 2? So that's 1. What's the square root of 0? 0. What's 0 divided by 2? Still 0. Look at that. My first coordinate is 1, 0. Oh, what? This can't be real. Okay, that 30-degree angle, I have a root 3 over 2. Well, I can't simplify the square root of 3, so we leave that as root 3 over 2. But that y-coordinate, the square root of 1, can I take the square root of 1? For sure. That equals 1. Check it out. That's the coordinate at 30 degrees. This is kind of neat, isn't it? A little bit. Like, why does it work? I don't know. It's magic. That 45-degree angle, root 2 over 2, comma, root 2 over 2, those don't simplify. They stay put. Up at 60 degrees, the square root of 1 is 1. That's just 1 over 2, root 3 over 2. And finally, that top 90-degree angle. Square root of 0 is 0, divided by 2 is 0. The square root of 4 is 2, and 2 divided by 2 equals 1. So 90 degrees is the point 0, comma 1. Isn't that amazing? Yes. What? Why? How does that work? That's so easy now, isn't it?
I'll get that to you.
I know. I mean, if you take the 0 and the 90, the 180, and the 270 coordinates out, those are easy. Those are just ones and zeros, right? So like you all know those coordinates. The only ones you really need to keep straight are these 3 in the middle. And also 45 degrees, if you think of that as a right, 45, 45, 90 triangle, that's the only one that has the same. And then the 30 and the 60, it's the same two values, just flip-flop. So the only thing you really need to keep straight is for the 30 and the 60, which number comes first, the root 3 over 2 or the 1/2. And if you get that, then that's pretty much, it's the same values around the whole unit circle. All right, so we've got all the coordinates for quadrant 1. Well, what about the rest of this circle? There are 3 more quadrants. Well, here's the cool thing. You're going to take those values that we already have, and you're going to imagine this dashed line, or this line of symmetry, right down the middle of your unit circle, as if this were a book. And you're going to fold that right page over to the left page. Take those values on the right and fold them over to match them up on the left. So like this coordinate that's up here would match up with this angle right here, right? If you folded them together, they would lie on top of each other. So you write those same values, the 1/2, comma, root 3 over 2. That next angle down would be the next angle down over here. That's the root 2 over 2, comma, root 2 over 2. That third angle will be right here. That's root 3 over 2, comma, 1/2. We're just matching them up, just shifting them to the left. Then finally you have 1, 0. It's going to go right here, 1, comma, 0. So start by just moving the exact same numbers over, just flipping them over. But now the last thing we need to do is just think about the signs of these values. if you just move to the left, if you're in quadrant 2, which coordinates are negative, the x's or the y's in quadrant 2? X is negative. What about y in quadrant 2? Is y positive or negative in quadrant 2? It's positive, right? Because you're still going up. So all we need to do is take every x coordinate and just put a negative sign in front of the x coordinate. And then you got it. That's not difficult, right? Do I what? Oh, we got plenty of time left. What about quadrants 3 and 4? Yep, it's going to be the same thing, but instead of flipping left and right, we have to flip from like top to bottom to match them up. So then this value here would be this one here. Think of like those both have that 30-degree reference angle. So like this is closest to the x-axis, then this angle is the closest to the x-axis. So they're going to have the same coordinates. You just have to think about positives and negatives. And so this would be your root 3 over 2, 1/2. And that's going to be right here, root 2 over 2's. And then your 1/2 and root 3 over 2. That'd be that next one down. That would be the 60-degree reference angle. And last, we got that 0, 1, 0, 1. But this was quadrant 3. What are the signs of x and y in quadrant 3? Good. They're both negative. So go to every one of those coordinates in quadrant 3 and make them all negative. Oh, and I left these positive for demonstration purposes, but everything here is negative, 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 negative. I don't make a negative 0. There is no negative or positive for 0. Put negative signs in front of everything. Then you just flip those all over one more time to the right, and you'll get your last values. In that last quadrant, what's going to be positive and what's going to be negative in quadrant 4? X's or Y's, what's negative in quadrant 4? Just the Y coordinate. So negative, 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 and you're done. And that's it. That's the unit circle, everybody. Da, 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 da. That's going to be so much fun. This is just a reminder about the signs on which one's positive and which one's negative in each quadrant. But just think of like plotting a point on the coordinate plane, and you know x is positive to the right, negative to the left. Y is positive up and negative down. And that's it. That's the unit circle. You just created that entire thing. It's awesome. This is totally something that you need to practice to get better at, but it's not overly difficult. You don't have to actually sit there and memorize it. You just think about how it's constructed, and you all are capable of recreating it. And that's the intended skill here. Can you recreate the unit circle? Because once you have it, it's extremely useful then for these trig functions. Now, as far as homework, this isn't something I can give you homework on like a Delta Math, because you can just look up those values, right? You can just write them in, type them in. That doesn't work. So this is going to be one of those honor system things, but there's not going to be a graded homework assignment to practice this. But if you don't practice this, in 2 weeks, you're going to have a test on it. And the test unit circle creation is 90% of your grade, where the homework is only 10%. So you're going to want to practice this on your own, recreating it. Now, if you notice the back page of this note sheet, I gave you a giant blank unit circle for you to practice. In the back of the room, on my counter back there, I've got yellow sheets with more of these blank unit circles if you want to practice it. I've posted a copy of it online on my P-Learning calendar, a blank unit circle if you want to use it. But also, guess what? These are really easy to create blank ones on your own. All you have to do is you draw a circle, right? That's easy. You draw a plus sign in the circle, also pretty easy. And in each quadrant, you draw 3 lines near the middle. And that's your 30, 45, and 60. So you can easily just make these yourself and then try going around the circle and writing all the values down. Degrees, radians, and coordinates at each of those points. All right, so that's going to be the goal. Once you have that, once you know that, then you're going to be able to figure out each of those trig functions instantly. That's it for today's lesson. Any questions? You may, yeah. Anyone at home? Any questions?
No, sir.